As your flight approaches the regional airport where you'll switch to a for this like 6 or 5. For 5, yeah, fair enough. As your flight approaches the regional airport where you'll switch to a much larger plane, customs declaration forms are distributed to the passengers. The form asks you a series of 26 yes or no questions marked A through Z. Okay. All you need to do is identify the questions for which anyone in your group answers yes. Since your group is just you, this doesn't take very long. Okay. However, the person sitting next to you seems to be experiencing a language barrier and asks if you can help. For each of the people in their group, you write down the questions for which the answer is yes, one per line. For example, Oh, okay. So, for each people in their group, you write down the questions for which the answer is yes, one per line. Okay, so 6 questions to which anyone answered yes. A, B, C, X, and Z. Duplicate answers to the same question don't count extra. Each question counts at most once. Wait, so is this the answers for one person? And then the first person answered A, B, C, and X? Another group asks your help, then another. Eventually, your collected answers from every group on the plane. Each, yeah, it's one line per person. Then this answered yes to A, B, C, and X, right? Okay. Collected answers for every group on the plane. Each group's answer are separated by a blank line within each group. Each people's answers are on a single line. For example, okay. The list represents answers from 5 groups, 1 through 3, 4, 5. Okay, first group contains 1 person and answered yes to questions. Okay, this is a lot more clear. Second group, 3 people combined the answer yes to 3 questions. Third group, yeah. Okay, in this example, the sum of this count is, which counts is this? Oh, so how many unique? So for group 3 is 1 to 3. Okay, so how many unique questions have the group answered yes to? Okay. For each group, count the number of questions to which anyone answered yes. What is the sum of those counts? I really wish I knew what part 2 is. Because this could be done in so many different, like we could do this in so many different ways. I guess we can just use sets, right? By accident, I misread part 1, and so I did part 2 before part 1 without knowing. Right, so I'll just use sets here, right? A list of sets where, and then it will be very easy to count. And then if part 2 they'll ask things that are not well represented by sets, I'll be annoyed, but it's not going to be a huge deal anyway. So what's the input? Again, let's have a quick look at the input. Oh, it's just, lines. Well, we need a parser for this, like an actual real parser. Yeah, it does lose info. You lose the info of how many times you answer the same. Like if later they'll ask me how many people answer the same question, or something like that within a group or something. Then yeah, I will lose info, and it will be annoying. Or do you mean treat each person as a set? Maybe that's what you meant. Okay, yeah, I get. Okay, so let's see. Okay, do I need a parser for this? This is kind of annoying, right? Because like they use the new line delimiter here, like between persons, and then there's like double. Like we could, but span only works once, right? it doesn't do it recursively. It's kind of like we could use we could create a recursive span function, which instead of returning tuples, it could return like an array. It's not too hard to write. Yeah, let's do that instead of using parsers. We get to write a few extra recursive functions by hand. So module day 6 where I don't think I don't know of any, so there might be, but I don't know of any. Okay. I'm very annoyed Haskell doesn't have an easy way to do this. So this is a terrible name. We'll figure out a better name later. But I want from string a list of okay. So what do we need? We need so we need each, like we need this as a group, right? Which is a list of lines, right? So this is a list of string. So if I need groups of that, I need a list of string, right? Case, what was it called? The one, oh, span, I think we used. Will that even be enough? That's gonna give us the first thing, right? But we need a group. Oh, what if we do lines first? So if we have something like, okay, I think I have an idea, actually a better idea. Because with lines, we'll get stuff like, let's do 1, 2, 3, 4, 5, and that's enough, I guess, whatever. Oh. 1, 2, 3, and then double lines. Okay, cool. Yeah, so I think we need to do lines first, right? And then we need to do span of not equals to empty to this, right? Of actually we need to use two functions, but that's fine. I guess we need to do go lines of I first, right? Where go is something from string to string to this as thing, right? And then go, we need something like input is well, input is case span not equal to an empty string, right? Over input, and then we get what? We get a like group, some group n, right? Let's test it. Span, yeah, span over. Let's copy this thing, right? Although the last one, yeah, we'll have to figure out the last one. So this would be like one of the groups, right? And then we should have another array here of this and rest, I think. Although we might also have an empty thing here. Maybe. Yeah, but I guess we need different cases for them. So if this is the case, then we need to do gn and then do go over rest. It's go, not gp. Although go over rest is a... No, it needs to be like this, I think. No, wait. It's like this for sure. Why is it not liking here? Rest is a list of strings. Yeah, this should be right. I'm not sure why it's complaining about. You have an a comma. Oh, right, here you mean, right? Okay, yeah, here. And here we should have, so if okay, so what if this is the last group? So what if we don't have any of those? Then that would be just an empty list, right? So we could do... Would this be enough? I'm not sure. We can try it out. This needs to be like this, I think. Wait, here. GN and this, right? I'll try out different options. Why is this non-exhaustive? Oh, right, because would it always be the case that this is like this? GN, I guess. And then is there any other option, or the option that this doesn't exist, but I'm not sure. All right, yeah, we need to do this. You're right. I'm fairly sure this is still Oh, we're missing some parentheses here. Okay, I think it's still not exhaustive in the sense that but I think in all other cases this should be an error, considering our input, or rather considering the outputs of span. Okay. Sorry, we need like for this. Right, okay, you're right. So if this is... This shouldn't be an error, right? This should be just GN also. So maybe, yeah, maybe we can just have this. Yeah, I think this is right. Because if it's not like this, then we need to throw it away anyway. I'm fairly sure. Yeah, I think so. Although they're the same, unfortunately, right now, with the redundant bracket. Oh yeah, okay, sure. Is this correct now? So if we have like 1, 2, 3, 4. Okay, so what if we have extra new lines at the end? We are... Okay, let's assume that we're not going to have that weird of an input. I mean, it still works for empty training lines. It's just if you have too many of them, when it gets to be a slight problem, but I don't think that's a problem. Okay, we can use this for parsing now. Okay, so let's go back to, okay, so I need to parse IO, and I think the plan is to do, yeah, I like the idea of set of string like this. Yeah. Okay. Day 6. And then what do we want to do? Well, we need to do double lines, I guess, right? Right. Set char. Yeah, you're right. Set char. Okay, so now we want what, from list, I guess, just set from list. Set S, there we go. Although you probably need a map over there somewhere, right? Maybe double map. Okay, let me think for a second. Okay, so double lines is what? Double lines is, so we have a list of strings. So yeah, we need map. Oh, whoops. From list. That should be fine. Okay, cool. Okay, so now we have a list of set of chars where each list represents a group and each set of chars represents, well, each top level list represents the choices for a whole group. The list represents a group, right? These are all the groups. This is a single group and this is a single person, right? The inside of it. Fold L. Yeah, the only problem I have with that is that plus, well, again, we didn't bother with like what's slower and faster, but yeah, I don't think it really matters. Okay, so what do we need to do? Because I kind of forgot what we were doing while working on implementing this. So the list represents answers. Okay, so the sum for this count is, so count the number of questions which anyone answered yes. Oh, so we just need to, okay, so for each group we want to do a set union, right? So we need to do a union inside the inner list of sets. We want to do union to get all the like unique questions, and then over the resulting set of answers per group, we need to count all of them and do a length and then a sum, right? So solution 1 would be something like from set char to int. Whatever, let's call this input, right? So here, what do we want? What did we say want to do? Well, well, at the end, we want to, let's think about this like this, right? So we want to sum, right? Over, so what's sum again? Yeah, okay, that's fine. And then we want to do length. S dot map. What's the sets? Why do I have so many things open here? Data.set. What's this, like? Yeah, this one. containers. Okay. Deletion query size. Okay, so it's size. Size. Okay. So is there a way to do union now? Union. Oh, it's even. Well, isn't this? Oh, you actually typed that out as well. Isn't this super handy? Unions, right? So you need. Oh, actually, instead of mapping unions, yeah, you're totally right. Okay, and then I guess I can just do this, right? So you could do something like day 6 that solution. Well, did we not? Did we not save this here? What's going on? It's also the semi-group for sets. Oh, cool. I didn't know that. Wait, why did they choose union and not like intersection or something? Isn't that a bit weird? Ooh. Wait, this file does not exist. Did I not save this? I probably did not save this, right? Union is a monoid, intersection isn't. Wait, why isn't intersection a monoid? It's hard to represent, but isn't it a monoid as well? Yes, it is. It's the list of all possible elements. Or the set of all possible elements. There is no set of everything. There should be a set of typed everything, right? But I guess I see what you mean. Okay, let's see if this is the correct result. Cool. Yeah, exactly. That was what I was thinking. But yeah, I guess it's not as general as union. Yeah, it should exist for enumerable finite types, for sure. That's hard to represent. Yeah, of course, that's hard to represent in Haskell. Okay, so this represents. Wait, what's part 2? Okay, part 2. As you finish the last group's customs declaration, you notice that you misread one word in the instructions. Well, isn't that... You don't need to identify the questions to which anyone answered yes. You need to identify the questions to which everyone answered yes. So using the same example as above. Oh, we only need to count where everyone went yes. Okay, so now we need intersection, right? So now we're exactly at the problem we were talking about earlier, right? Fold L1. Why is it 1 though? Shouldn't it be 0? Since we're doing sum, aren't we doing a sum? Oh, fold L1. Okay, never mind, because there is no unit. Yeah. Two. So wait, intersection. Oh, we still need to map. It was the problem now? Yeah. Where do we need parentheses? Oh, I guess we need to map twice, right? So, that, oops. I guess this is what we need to do, no? But why wouldn't it be the same as mapping? Wait, why is this not the same as mapping size and then mapping that? Shouldn't it be the same thing? Am I crazy? And why didn't it work? Like, shouldn't this be the same thing? Oh wait, I'm crazy. Yeah. I have the different bindings here for this. Okay, there we go. Wait, can it actually do that for me? Oh, cool. Cool. Okay, fair enough. I forgot. I think I've been doing this for too long. Okay, so now let's try to do like solution 2 instead. Okay.